Hi, I'm John Dawson. I work at M&GPrudential as a fund manager within alternative credit. We've been working closely with the Microsoft team and also our data scientists here to really try and take ideas from investment professionals, so fund managers, credit analysts, originators, and also our client teams as well, and turn those ideas that they've got into machine learning production-worthy pipelines.
Hello, and welcome back to the Machine Learning at Microsoft YouTube channel. Today is a very, very special episode because I'm here on one of our customer engagements with Chris Gell. Chris is from M&GPrudential.
Yeah.
And Chris, what do you do?
So I am the AI and ML platform engineering lead here at M&GPrudential.
Fantastic. And what are we here to do this week?
Yeah, so this week we're focusing on how we can enable our data scientists to deploy models into production.
Brilliant. I quite often say that the main problems in machine learning are, number one, the model does something that we don't understand or intend. And number two, the models don't get into production because we have a dichotomy in data science. We have some data scientists that just use Jupyter notebooks and just, they're almost like power users. Their models don't really go anywhere. And then we have another brand of data science, which is the one that I think you and I are fans of, which is seeing machine learning as a form of software engineering and trying to take this engineering culture, which is quite mature in the software world, and to transplant it onto data science.
Yeah, and it's a very interesting challenge because in many respects they're very similar, but in many respects there are nuanced differences that make getting machine learning models into production, particularly in a regulated organization like ours, more difficult. So, for example, we need to know the data that we use to train the model. We probably need to know the hyperparameters and any metrics we use to evaluate the model performance. And if you think about the data science workflow, we might do 1,000 iterations on the same model. So it becomes incredibly difficult to track all of that telemetry without having some sort of platform. And what we're doing today is we're trying to focus on how do we do that in a way that's super slick and super easy for the data scientists so they can focus on creating cool models that add value to this organization.
Is take the Microsoft team, take the technical expertise from within the company, put them together, lock them away, and just give them the challenge of how can you make the user experience for a data scientist as good as possible. And the team have pretty much cracked it, I'd say. So I'd like to think over the coming months, we can actually take some of those ideas that we've got that are basically going to help us make better investment decisions on behalf of our clients. And we can actually start deploying those, putting them onto investment professionals' desktops, and they can actually start to use them as part of their day-to-day investment.
What I've been doing this week is trying to find a way to make the productionization process as easy as possible for people working in the data science realm without having to learn a huge amount of software engineering processes.
I am the engineering lead in Digital Office. Prior to that, for the previous, 15, 16 years, I was the head of engineering at M&G. Yeah, I think we look back on the journey we've been on I think we put a huge amount of effort into the people. And we did the big push into Agile, must have been 6 years ago. And it must have been 2 years ago that we saw this tremendous opportunity by the migration onto the Aladdin platform, that we had a bunch of very talented and highly opinionated engineers who said, this time we've got to take this opportunity and we're going to go to the cloud. We're going to do it. This is a big step for us. We're going to back ourselves. We're going to back our sort of Agile beliefs. We're going to back ourselves on an API-centric sort of conviction, and we're going to back ourselves. And the third principle we had was PaaS first. So we had Agile, API-centric, PaaS first were our guiding principles 2 years ago. And I think in hindsight, those are three very good principles which we still stick with now.
So my role is to kind of work with Microsoft's AI stack, helping customers understand it and prototype and get to grips with it, and working on those first use cases, those anchor use cases, and really just getting them familiar with the technology and successful.
So we've been doing some really interesting, exciting work around Kubernetes clusters with machine learning. Been really interesting actually to work on this because we're doing some things that I've been quite interested in getting my hands on for the last few months, which is working out how we bring machine learning workloads through a DevOps process into a Kubernetes cluster. So how do we containerize them, but then how do we kind of productionize that as well?
The lessons we've learned is our conviction is it really is heavily about the people. And it's really about having people who are passionate, who are talented, who care. And I guess for us, it's really important that the key partners we have, they really lean in and they want to help us because they have empathy. And they have empathy because they care, they connect, and there is a mutual respect and trust on that basis. And we see it's very important to have those partnerships in place are far more binding. I want to help you because I have empathy with you and I care about making you successful. To us is far more important than there's a contract we signed. I personally don't think that's a particularly great way of having a sustainable model.
So the first functionality that we have in ML Ops is to come in as a data science and just set up your whole project and repo so that's ready to run for you without too much work. So at the most basic level, we're just going to say ML Ops in it and then give our new project a name. And this library actually already has a template installed with it. So that's going to find us a basic project and tell us what to do next. So we're going to go into our...
So what happened when you said ML Ops init?
So that's just an initialization script that we have here.
Okay.
Which sets some environment variables, installs some packages that we're going to need, copies from the template directory into the directory that we're using. And yeah, that's pretty much it.
Okay.
So now that that's all set up, this is a template was built ready to run. So we can actually just go MLOps run, and that's going to get us our first go of this experiment.
Got it. So when you create this repository,
Mm-hmm.
it will create the project and the repo and everything in Azure DevOps, and it will set the origin on the local Git repo to be DevOps. So when you do a push, it will trigger off this non-interactive process, and that will end up in production.
Yes, if you wanted to.
If you wanted to. So you have a local and a kind of an interactive instance, and then when you're happy with the model, you push it into the repo, and it will be containerized. It will go into the container registry. It will go into Kubernetes, and then people can access the latest version of the model through the API routing in Apogee.
Exactly.
And that's the full process.
Yes.
Amazing.
The image has already got that company amplified. It's got the scoring scripts and everything. It's already automatically generated.
So that run's gone through. If we wanted to try and add in another parameter, we can add in this very easily. So our entry point is alpha. Last time we ran it at 0.005, so this time let's try 0.06.
So it's cloned a template project from an external repo.
Yeah.
Copied it into a local repo on this machine. You've now run it twice, but the second time you ran it with a different hyperparameter.
Yes.
So it's trained the model. And what happens when you train the model? What's the output artifact?
Well, I can show you the output artifact right now. If we go to MLOps show, it's going to give us a local host address because this is all running locally on my machine.
Okay.
And we can get a bit of a UI and see what these trained versions have created.
Okay.
So here we have the two runs we've just run. If we want to see which hyperparameter performed best, we've got our mean squared errors being output, so we can compare that as a graph, or we've got an R2. But also what we can do is if we click into this specific run, then we have saved as an artifact here, ML model, a conda file, and this is a pickle file of the whole model. So we've got a record of that. So we kind of identified the key functionalities that they thought they'd need. So first off, instead of them having to set up their own project, just a simple initialization command, which you can clone from a template or already has a template installed that then copies into your library. So you've got a setup of something you can just run straight through and then go in and edit that into the actual model that you want. After that, you want to be able to run that using ML Flow so that all your runs are recorded and you've got all those parameters and metrics recorded. So just a simple way to do that, you can either just say, MLOps run at the most basic level or add in a parameter that you want to change. Then after that, we want the ability to see these runs in the UI and also to be able to serve this up as a API in a dev environment rather than waiting for something to be productionized before people can then go in and build the app around it. So hopefully that'll be useful, being able to serve these up and see how they would interact with the development app.
I see. So there's a whole kind of sandboxed approach. So you can serve the model up and experiment with it on your local machine.
Yes.
And then you can also push it up to Databricks as well.
Yeah, exactly. So you want to have a kind of a local version you can use, a kind of interactive Databricks version that you can use to kind of start doing some fast experimenting. And then once you've kind of got something that you feel is ready to have a real look at, you can then push it through the ML Flow pipeline. And then you've got a record of experiments that you know what they're doing, and you can look through and choose the best one and compare those. You've got a set record that you can kind of always refer back to and know exactly how you got there. Right. And then maybe push it to a non-interactive version, and that's when you start using your build pipelines where things can flow through automatically and your job is kind of done as far as the data scientists are concerned, and they don't have to pay too much attention to what happens after that.
So, we want to empower our data scientists to be able to get those models into production. And to do that, we need to see them as first-class citizens within the software engineering lifecycle. In many respects, what they're doing is software engineering 2.0, right? They're generating software, but using machine learning to generate code that we couldn't otherwise do just as humans.
Some people believe that data scientists should stay inside Jupyter notebooks and have this very academic, interactive form of writing models. And the alternative is to force them to be software engineers and to use IDEs and source control and so on. And I think originally we were taking the former option, and we've gravitated towards taking the second option. But what we've done is we've focused a lot of attention on improving the user experience for data scientists.
Yeah, I think so. And I think that's, there's a challenge in trying to find the right balance between those two forms of working. So historically, we've been working in the former, which is a highly interactive Jupyter notebook-like environment. But in some respects, that sort of led us into what we call the lab trap, which is we have great ideas and we can generate great prototypes, but there's no way that we can take what is almost sometimes like a stream of consciousness way of working and turn that into something that can go into production. And so what we want to be able to do is not take away from that process as much as possible, because in many respects, it's that kind of creativity, that exploration that sort of, really makes data scientists quite successful. But at the same time, we don't want to be in a situation where you've got this kind of, in some respects, huge amount of friction between a data scientist and an engineering team in order to get this thing that could add huge amounts of value to the organization potentially into a place where it can actually generate that value. And so what we want to do is try and strike that balance. And what we found is that you can still have an element of that interactivity, and we can still enable data scientists to use different tools and frameworks. And you can also provide a kind of a paved route to make it easy for that to go into production in a way that we feel comfortable as engineers and as a regulated organization.
And so we started thinking very much around how we can sort of break this up and the responsibilities in a way that makes sense and is secure, but also means that data scientists don't need to know too much about ML engineering and cloud services to try and make it so that they're more autonomous and able to do their job better.
And I think there's been a definite pivot in the organization towards machine learning and data science over the last 8 months or so.
Yeah, I think so. I think it's like we like to see ourselves as how do we differentiate? And then we've become traditionally been a very analytical organization. So for us, it's a natural progression into using data to help drive decisions. And then once you start going into the whole data drive decisions, you naturally go down the whole experimentation, sort of continuous experimentation concept, and the whole concept of data science in the broadest thing makes so much sense on that basis. So it's a very natural continuation. It's still relatively early days for us, but I'm absolutely convinced that this is going to be, let's say, software engineering 2.0. This is very much the future. Early days for us, this is definitely where I think we should be committing.
Okay, so this is the architecture that we've been using on this particular engagement. So we started thinking about an organization. So that's a company that's typically broken down by multiple divisions. And so therefore, each of these divisions are likely to be wanted to be fairly autonomous in terms of their structure. And the way we've started thinking about is having a bunch of services that essentially manage across by the cloud architects. These are things such as AKS, which is Azure Kubernetes Service, and ACR, the container registries, and that would be held centrally as part of the divisional structure. And this would be provisioned once, probably, by a cloud architect. Then we fall down into another area, the area domain of the ML engineer. And in this space, we'd have a series of workspaces, typically think of them things like project teams. And these teams would need, as part of that, a number of the Azure services. So things we're thinking about are things such as Azure ML workspaces, Databricks environments, a DevOps pipeline and build processes, and potentially ML flow as well. And that would be part of the workspace area. And then dropping down into the data scientist area. Here, what we're expected to be able to see is that the people to be able to work offline. They would be able to provision new projects. And within those projects, they would be able to define experiments and be able to submit those experiments up and into the pipelines, where effectively we would be able to drive through, build containers, and push them up into the container repository and up into AKS.
And I suppose the big challenge here is it's really, really difficult to facilitate this non-interactive phase of data science, because it needs to be written in such a way that models can be automatically retrained, that tests can be run.
Absolutely.
And some of it is about personas and role fragmentation. I mean, this isn't something we've touched on yet, but, you know, in an organization like M&G, there'll be operations people. There's a kind of engineering culture. There'll be people that are just monitoring what's working in production. And at some point, even if the data scientist got run over by a bus, the model is in production, and there are people who are just monitoring things like unit tests and making sure there's no downtime. It's actually a completely different mindset.
Yeah, and I think, you know, it's how can you go through that entire workflow in a way that has the least amount of friction for all of those different types of roles that exist within the organization for good reason. You know, the ops guys, they need to be able to understand how these things came into being. They're going to be enabling them to run in a production environment. But at the same time, if you try and shoehorn someone who is highly creative, works in a highly exploratory way, then you're not going to get the best out of them. So a lot of thought is going into this space, which is actually you kind of want to allow people to play to their strengths and have something that kind of glues it all together in a way that people don't feel that friction, and actually they can just focus on the things that they're doing to add value to the organization.
Work through, so from setting up a project in a really easy way, setting up a Git repo, and then taking the commands that they might need from a project like ML flow, some Azure commands, so they can clone and build a pipeline without having to go into the back-end world of Azure DevOps and really abstract away the complexity, give them a simple structure to work through. If they feel like they need to go in and edit it, the backdrop's still there, but just got a simple set of commands that they can use.
Okay, so because the context here is we're making data scientists be a bit like software engineers, but we are trying to make it as simple as possible, and we're scaffolding the whole process. So without this effort, they would have to create a DevOps project and a repo and build and release pipelines and continuous integration, and they would have to set up ML Flow, and they would have to know how to submit their jobs to Databricks.
Yeah, I mean, even a software engineer balks the first time that they're trying to set up a DevOps pipeline. So you're trying to make a simple pipeline that they can then clone in as easy as possible without necessarily knowing the detail that it's going into in the backdrop. And they can use that, and hopefully there'll be no issues, and they'll never even have to see that there was a whole Azure DevOps repo behind them all the time.
But the key thing really for me is this demarcation of different roles and responsibilities. So we've got a cloud architect whose job it is to build and manage from a lot of the core central services and make sure security and all those things in place. The ML engineer, who's very much around the ML pipeline process, the non-interactive, that's their responsibilities to manage that part of it. They will have some experience and knowledge of data science, but not as deep as the data scientists.
Yeah.
And therefore the data scientists themselves are now fully empowered here to be able to do the work, but to be able to do it in a way that's actually consumable by the ML engineer pipelines.
Yeah, I very much think so. I mean, as you can see, I've got a lot of grey hair. I've been around since development engineering since 1987.
Wow.
And I think it's just, for me, the most exciting time to be in technology and engineering there has ever been. And the things that are previously just unthinkable are now becoming possible. And I think it's really, as you said, there are solutions that we just couldn't even discuss or imagine. People are now actively considering doing locally, some of the people we're going to meet today, etc., on that basis. I think it's a really exciting time.
So to start off with ML Flow, ML Flow provides sort of three core components: the concept of projects, and you can think of these as a standard structure for organizing a machine learning project. And if you come from the engineering world, I tend to use the Maven in the Java world as being sort of an equivalent in that space. You've got this concept of tracking, and tracking is how do you track the parameters, the data, the artifacts for each run of your experiment or your training loop, and being able to query and compare performance and compare runs. And then the last piece, which is models, which is really just a standard way of packaging up different models coming from different frameworks in a way that can be deployed in Azure Machine Learning. It could be AWS SageMaker. It could be even taking that model and plumbing it into a data pipeline as part of a Spark job, right? And so we like that because it's agnostic in terms of the underlying frameworks that are being used. It's agnostic in terms of the runtime. But what we've tried to do is make that as easy as possible for the data scientists to use. So we've wrapped that up in what we've called the ML Ops CLI, which enables a data scientist to turn up on their desktop and say, I want to create a new project. And with that project, suddenly they can go into that project, they can run that project, they can start adding code to that project, and they're already up and running. They can even serve that project up locally as a RESTful service and check how it performs and add bits and pieces like feature extraction if they need to add that as part of the scoring process. And once they're done, that can be checked in to source control, and we can create a standard build and release pipeline that will allow them to take that project, create a non-interactive training run of that, capture the artifacts, keeps the engineering guys happy, keeps our compliance guys happy. We have a source of truth, how this model was created, and we can take that and we can deploy it into many different environments, many different contexts. And that's what we've been doing this week, is how do we make that as seamless as possible so that we can empower the data scientists to hook into that process and focus on the thing that they're doing, which is solving real problems using machine learning.
Because I've seen a lot of companies try to put ML DevOps and data ops processes into place. But one of the things that perhaps they don't focus enough on is this kind of persona-driven workflow where data scientists can actually create their own resources without having to go cap in hand to IT or the data engineers.
Absolutely.
But I think another thing that we've focused on this week is the actual productionization target for these models. And we've looked at Kubernetes, and we've looked at Azure Container Instances, and we've looked at the app service containers, which
Yeah.
is another potential option.
Yeah.
But what's our progress been on that?
So we're looking like we're settling on Kubernetes using Azure Kubernetes Service. Really, the sort of driver behind that is its integration with Azure ML and the fact that we're using Azure ML as what we call a model registry, so a place where we store all of our models and their versions. And then we can get lineage using AKS in terms of that model is deployed to this particular Kubernetes instance, and it has the whole lineage in terms of this was the model, this was the training run that was produced. And we can do things like capture the data, capture the requests, capture all that telemetry.
Yeah.
So over time, we can monitor these models in production because, once a model goes into production, you kind of said earlier, that's just the starting point, right? Models do need to change over time. Our assumptions around the data that we use to change them, to train the model change over time, right? We need to be able to understand how these things are performing in a live environment. And without being able to capture that telemetry, it's impossible. And so the reason why we settled on Kubernetes really is it's just hooked into seamlessly into Azure ML. ACI is it seems to be a great thing to spin up something and play with it, but we couldn't necessarily feel like we had the control that we would have with AKS. And then the app service plan seemed like a good option, apart from the fact that it wasn't quite integrated with AML at this point in time.
Big believer in bad systems, bad behaviors, because a lot of data scientists will take the path of least resistance.
Exactly.
And if you let them do what they want to do, they will spin up all sorts of infrastructure all over the place, and it'll be a security nightmare. And the really smart thing to do is to create a fantastic system and user experience for them to do their job as well as possible. But
smart people will find ways to solve the problems they've been asked to solve, regardless of whether or not it's sort of within the interests of the way we want to manage our software estate, etc. So rather than try and fight against it, how can you create that useful experience that keeps them happy, enables them to be productive, at the end of the day, keeps everyone within this organization happy, including the compliance, the security guys, because actually the only way we're successful is if we work together. From our perspective, this has been a great week working with you guys.